Today we will be looking at operations on functions, specifically finding the sum, difference, product, and quotient of functions. So here we have our chart on the key concepts and operations on functions. You have seen an old notation of this, which we will review, and then I will be introducing the new notation. So for addition, we have f of x plus g of x. Okay, that's our old notation there. We now know we can write it as f plus g of x. Okay, so those notations mean the same thing. Looking at subtraction, you're used to seeing f of x minus g of x, which we will now write as f minus g of x. Moving on to multiplication, f of x times g of x is your old notation. We now will write this as f times g of x. And finally, division, we have f of x divided by g of x, rewritten as f divided by g of x. Okay, so there on the left you have your old notation. On your right you have the new notation. Let's try to get more familiar with these. Alright, so we have f of x is x squared minus 4. G of x is 2x plus 4. Example 1 is asking us to do f plus g of x. So I'm going to start by writing f of x. Okay, so that's my f of x function plus g of x. G of x is 2x plus 1. Okay, now we combine like terms. So we have x squared. I only have one x squared term. I don't have a term to the second power from my g of x function. Now I add 2x. That's my only x term, is 2x. And now I'm going to add my constants together here. Combine those to get minus 3, so my answer there is x squared plus 2x minus 3. Alright, moving on to the second example. Here I have f minus g of x. Okay, so I'm going to start with f of x again. Our parentheses are really important in these problems, so make sure you're very precise in using them. You'll see why in just a moment. Okay, so once again in blue, I have f of x, in green I have g of x. Alright, and what I'm going to start by doing here is distributing that minus sign to g of x. So I have x squared minus 4 minus 2x minus 1. Now I'm just using the different colors to show you that we still have f of x and g of x. I haven't combined any terms yet. Okay, and now that I've distributed that minus sign, I can combine my like terms. So I only have one term to the second power, that's x squared. I only have one x term to the first power, that is 2x. Notice that's a minus 2x. I now will combine my constants, minus 4 and minus 1, to get minus 5. So my answer there is x squared minus 2x minus 5. Alright, example 3. We're using multiplication. So I'm going to write f of x times g of x. Okay, so you can use the FOIL or box method here. I'm going to use the box method. Okay, and here what I do is just multiply these terms together. So 2x times x squared we know is 2x to the third. 2x times negative 4 is negative 8x. X squared times 1 is x squared. Negative 4 times 1 is negative 4. Alright, I look and see, can I combine like terms? No, I can't here because I have an x to the third term, x squared term, x to the first power term, and a constant. So now I simply write them starting with the highest degree. So I have 2x to the third plus x squared minus 8x minus 4. Okay, and that would be my answer for example 3. Example 4, I'm dividing. Okay, I'm going to zoom in here. Okay. Okay, so once again in blue, I'm going to have my f of x. So I have x squared minus 4 divided by 2x plus 1. Okay, so I look here to see if I can factor anything. We'll notice on the top this can be factored, so I'd get x plus 2 times x minus 2. You should remember that from what we've learned in chapter 6. However, what you should notice is that none of these cancel out, right? So if I had an x plus 2 or an x minus 2 term on the bottom here somewhere, I could cancel those out. But since I do not have either of those options, none of the factors here cancel out. So this is the simplest form here. Next, I want to direct us to this question of what is the domain. Okay, so the first thing I want to do here is set the denominator equal to 0. Okay, and the reason I want to do that is we know that we cannot divide by 0. So in order to figure out what cases to avoid when looking at this function, we must solve for when the denominator equals 0. So in this case, I have a denominator of 2x plus 1. So I'm going to set that equal to 0. I get x equals minus 1/2. So then my domain here would be all reals except x equals negative 1/2. So just want to emphasize again that x cannot equal negative 1/2 because then our denominator would equal 0, and we know that we cannot have a denominator of 0 because we can't divide by 0. Alright, let's pause here to let you try the stop sign problem on your own. Go ahead and do that. Okay, here are the solutions to the stop sign problem. If you have any questions about these, please ask about them during class. Thanks.